So let's have a closer look into how SNMP works. Remember, SNMP, simple protocol, similar to SMTP for email, SNMP is now for network management. So very simple, client server. The client here is our manager, so that's our client here, that's a client, accessing many servers running on all networked devices, with very, very simple commands. So we have a request for the content of an object, so a GET request. There we have to tell, okay, I want to access 1.3. and so on. Then we have something GET next. We'll see how this works. A set, and we have, a response, which is a good idea. If we ask something, we will get a response. And then something that is a notification, it's called here a trap. So that is an agent-initiated communication with the manager when something happens. And you cannot wait because GET is a polling. So GET set operations are initiated by the SNMP manager. So that's classical polling, asking for something or setting some resources. It reminds me to HTTP. And remember, HTTP is a bit new. And the trap is a notification. So that is a push notification. Remember, HTTP, the classical one, cannot do it. Push notifications are okay. Can be done. So with a trap. And this all works over well-known ports. It's UDP and it's port 161 for SNMP, and trap uses 162. So that's a very simple principle, and if you learned HTTP, this looks really familiar. So what do? The manager, our client, sends a GET request and specified object this and that. And then this goes over the network and the agent answers with the response. Okay, that's the idea. So for each object you request, you have to send a GET request and you have to fully specify it. Okay, maybe you can do it a bit easier, and this is where we have this GET next request, where we go basically in lexicographic order through our tree. That's the idea. So GET next replies either with a child or a neighbor of the object that is specified in request. So first the child, then the neighbor. Okay, but that's really cumbersome because you have to go through the whole tree, always asking GET next, GET next, GET next, GET next. So if you want to read out a whole device, this takes some time. And this is why SNMP version 2 included GET bulk request, so you can trigger a series of GET next requests going through the tree. That's a good idea. Then we can set a certain values if it's not read only. And then finally we have a trap, so that we have this push, and this GET bulk is just a series of GET next. Okay, so very simple, looks pretty much like HTTP. We also have packet formats, so that's not a big surprise, with a version number, and we have a community string for authentication transmitted in plain text. Okay, but so that's very high level structure. And then we have a command dependent part in the PDU. As always, this is more for looking up, not for learning packet formats, because this is something you just look into in the internet, how it then really looks like. A lot of the fields, the PDU type and errors maybe, and then the object names and request ID is important because you can send several requests and then you have to identify pending requests. You will get a result, similar like in HTTP, so error codes, either no error, which is good, or this read only, you cannot write something, bad values, etc., etc. And then some index telling you, okay, what's going on, and then the list of objects, so object names and object values. So very generic, very simple. How to use it? well, typing in 1.1 and so on. So a bit about the tools. So you can play with it. They are very simple tools, something like, well, all public domain tools, SNMP get. Yes, SNMP get is really, well, a way of getting the information. Here you have the get command and so on. And you have to say which machine. So if you want to learn something about all the machines, then you go to the machine, and then you can abbreviate it, indicating the part of the tree that is interesting, asking here system description, for example. Then it returns system description, blah, blah, blah. So that was a router in good old times, whatever. There are some more tools basically using this next command, and you can walk through trees, and then you will just say, okay, you specify down to a certain level in the tree, and you say, okay, now I want to learn all the children here, all these child nodes, and then you will get all the information, like uptime, like who's contact person, and all this stuff. So those tools exist since many, many years, very simple things, and there are also some simple browsers, so quite vintage, as you see, so because this are systems that are exist since many years, or on the right hand side a bit more modern, but this is exactly what you have here. So walk the tree, and then you can go through, in this case, through whatever firewalls, or you can check email stuff and do whatever you want. So then this is a bit more structured, a simpler way of going through this tree. Okay, this is something what you can do by hand, but we're in the context of network management. So typically we don't have the time to walk through trees, to check the objects. We want to do a lot more. And a lot more, that means exactly this, well, planning, simulating, or get, a quick overview of the network. And there are many, many products doing this, and this is just a snapshot from our compute center, what they see displayed on the wall, the status of the network. And well, you don't see the details, but you see that, oh, there is something going on up here, and then you can have a close look by clicking on something. You see again the structure of the whole campus network without being able to read the details. You see what the core routers are doing, you see the connectivity, etc. So there are many tools, and those tools, commercial tools, open source tools with different functionality, different components, and they offer a lot more than just SNMP walking through a tree. So they are important for administration, for many business and management processes, like how we plan new networks, do we buy something, management decisions, etc. Also software distribution. They all have similar challenges. So the main challenge is basically discovery of problems and polling of the information. How do we do this? There are some classical protocols, and we talked about SNMP. When we come to layer 3, internet layer, we'll have a closer look at ICMP. That is basically a control protocol. It gives us some more information about if something goes wrong. For example, a packet dies in a router because the TTL, the time to live, is 0. So there are some more protocols. Yeah, we can also use HTTP and many proprietary things, etc. So that's something quite important. Then we will check, we can check standard management information bases. Yes, private, and this depends on the vendor, how much there is from the vendor. So standard information is what about certain interfaces, because they always exist. But then vendor specific is, okay, for this very specific router we have this and this additional information, a lot of device specific things. And if you want to play with this, That's feasible. You can download, for example, Nagios open source system, and this is really the ideas here. Well, you can plan infrastructure. If you have a problem, you see the issues, you can sometimes automatically fix a problem, etc., etc. And it says you can ensure that service level agreements are being met. So if you promise certain uptimes, etc., then you have to take care that, well, you fulfill this service level agreement. You can try to minimize effects of outages and basically monitoring of the entire network. Just a quick overview how this looks like, just as teasers. You can install this, which is quite common for all these management systems. You always have this kind of topographical maps, maybe showing what's going on, where the different positions. You can click on certain locations. You see top alert producers, so what's going on, the top, so host status summary, how many hosts are down, how many are up. Also for interfaces, what's on with firewalls, etc. You can check, is there something going on from a certain source IP, which might be indication that there's a problem, that there's an attack, etc. Over time, you can log all this, so you can see, okay, things like disk usage, like how many log entries you get, etc. per 15 minutes, what the status of a cluster is. You can analyze networks, you can check what's going on in firewalls, so red is always bad, green is okay, and you can visualize this and then see, okay, how many problems are still unhandled, so someone has to take care of this, and what is the status of certain things, group health 100%, which is nice, but what is if we have critical things, and what is if something is down, and all these things. So this is overviews that helps you to manage huge networks without going into details. So SNMP, while being very, very simple, at least you have a standard. You can manage large and also heterogeneous networks. Why? Because we have a abstract syntax that helps us to basically hide these different ways of describing basically the same things, but in different ways. So simple standard can handle heterogeneous networks. We collect everything in a management information base, and we can access the management information base in a very simple way. That's maybe not too powerful, but it works. We have this hierarchical namespace. We have these unique names inside the management information base for our objects. But the problem is, as I mentioned several times, what about security? Yes, it's now built into version 3, but it was a real problem over a long, long time. Then these very simple commands, get and get next, that's not enough. So to really download a lot. And what about uploading? What about uploading complete configuration? And due to these drawbacks that actually led to replacement for it or newer developments, and the deployment of this takes some time, but netconf Yang, I will come back to this, is currently in the process of replacing SNMP and also replacing the way of how we describe things. A bit more in the next subsection. So looking back, so the very simple basic operations of SNMP, that pretty much looks like HTTP. Why not using HTTP directly? Or why not going for HTTP instead of SNMP? There are some reasons, several. Then try at least those simple command line tools to get a better feeling how this works. Well, we can also install Nagios or one of these tools. And then if you try the simple command line tools, think of what could be problems dealing with these identifiers, the management information base, the tree structures. Is this easy? Could there be some problems here? Then who creates the management information base? Who's responsible for all this? And then we come back to the drawbacks of SNMP. So why replacing SNMP? So what are the reasons? Why using now netconf, more and more netconf?